Good afternoon, everyone. I'm privileged to introduce Wagner Silveira. Wagner Silveira is a Microsoft Azure MVP, currently working as Principal Integration Architect at Theta. He has been working in New Zealand market since 2002, focusing on integration and service-oriented architecture, working across various industries, including healthcare, education, transport, utilities, and retail. So today he's going to speak about creating a processing pipeline with Azure Function and AIS. Please welcome Wagner.
Hello. So my name is Wagner Silveira. And I'm going to be talking about creating a processing pipeline with Azure Functions and AIS. And I might even throw a demo on that if we have time. So I'm the Principal Integration Architect at Theta, also an Azure MVP and Microsoft MCSC on Cloud Platform. If you wanted to get in touch with me, right, you have my Twitter handle there, WSilveiraNZ. You can get into my mail or my blog note2self.tech. But let's start because I know that you guys want to see the real stuff. What is the agenda for today? We're going to be talking about a case study for a government agency where we have to go through a series of evolutions of how the solution would work, starting with something that was like really easy, and they thought that was going to be working really nice, and then the reality check hit, and we have to adjust that solution to actually make sure that we're using the best technology for the job, right? Going to spend a little bit of some of the key components, what they make that solution actually work the way that they were expecting. And that's what we're going to do, maybe a demo too. And what if I was going to be doing the same solution today? Then I'm going to finish with some lessons. So about the case study. The solution requirements, what is it that the client needed? First, it was onboarding of external EDI messages, right? They needed to receive those EDI messages and basically process that all the way to some kind of big data repository. It should allow for different transports, although right now they're still using HTTP, but we shouldn't be locked to that, right? We need to maybe think about different ones. The message needs to be validated, translated, enriched, and routed, right? Vector, and the kind of stuff that we used to do on Bestalk with inbound pipelines, outbound pipelines. So it's that kind of situation that we had. It needed really good control and retry. So they needed to understand when things were failing. They need to set up retries on each one of those different pipelines and with different policies. And they need a notification of the failed messages. Need to audit the initial message and visibility where a single message was in the whole process. So in which stage a message is, they completed everything. It's on the routing, is on the processing, is the validation. So they needed that for troubleshooting. In summary, the design would look like something like that. Third party would be calling some kind of common API with a message on a defect, right? That API would be the hiding or proxying the inbound processing pipeline that would receive the message, validate, transform, and then push JSON into a staging repository. On that staging repository, it would be working with external repository with additional data, whereas the enrichment part would come, and would have another set of JSON now that was an aggregation of the original data with that second set of data, right? Inside the outbound processing, that would be probably splitting, routing the information into the outbound API, and then use some proprietary API to that big data repository. So that's what we had to do. So we thought, easy, right? API management, makes sense? Then The repository or the inbound processing could be probably a mix of logic apps, maybe service bus to pushing through the different steps, and integration account, because we were talking about the defect, right? Logic apps is there that has really good support about the defect, so we can work with that. On the way out, we could say, again, use the combination of logic apps and service bus to do the multi-stage and making sure that we keep and will be able to retry between stages, and hide the proprietary API there with API management again. Make sense? So it looks like a sensible solution. That's where from an integration or from a monitoring point of view, what we thought was we could use we could be using application sites where we needed to or where we allowed to, right? Because we could have application insights in the inbound and outbound APIs inside API management, but we need to use log analytics on the logic apps. Then we had the reality check. The first thing is the payloads was a little bit bigger than what they expected, right? They didn't analyze that in the advance. So the idea of using just service bus didn't fit that well. The second thing, the defect schema that they're using was like a quite recent version. So the bespoke integration account had not catch up with that yet. So the idea of using the integration account didn't actually fit anymore because we didn't have the schema to actually decompose of that and move into the other steps. When they thought about the volumes that they were starting to work, the operational cost of that was huge, right? Because at that point in time, we didn't have AIS, and we didn't even have the revamped pricing yet that the Logic Apps was bringing mid last year. Okay? So when they think about the volumes and the way that they're planning to create out that pipeline, the operational cost is starting to become quite scary for them. The end-to-end monitoring, it was again a solution that wouldn't be perfect for them because they would need to kind of use two components. And at that point as well, application insights and log analytics were not playing that nicely. It improved a lot over the last 6 months or so, or from the last year to now. But at that point, it was not exactly something that would work that well. So back to the drawing board. What we needed to redo here. First thing, API management was still like the right solution for that, right? So no problems here. But the inbound processing now, we needed to come with a different solution. That's where we thought that using Azure functions, because we could have like a dedicated model in combination with .NET components to process the pipeline, or to process that document, and also using a storage account with the service bus doing the claim check pattern would solve a whole lot of the problems that we had. On the way out, we just needed to use the Azure functions again to process the messages, and then API management would be there. From a monitoring solution point of view, now we should be able to get the application sites to work for everything, so it makes life quite easy. How that solution was different from initial, what are the things that make us change from solution 1 to solution 2? The first thing was Azure functions allow us to actually go to the market and find third-party components, right? Like a .NET package that supported that exactly in effect. So we have much more flexibility on that. The other thing is the claim check pattern, you just coding the claim check pattern to use a service bus and get the big message, you store on storage, and use service bus as the triggers for next steps work quite well. And the ability to actually lock the price into a dedicated instance that functions give to us also allow them to breathe a little bit better in terms of price, right? It was still expensive because it was like a lot of volume, so you're paying for what you're using, but they would know exactly what they're going to be using, so it's much easier business case to say we're going to be spending X instead of it can go up depending on the volume. The Azure storage was there to actually keep the big payloads, right, for the claim check pattern. And the application insights allow us to do a couple of things. One was like a single point to understand to store the events for everything, right? But also allow us to create some custom code and create across all your functions and create custom events that would say exactly what's happening at the beginning and at the end of each one of the components of correlating all of that together, and then you would have like an end-to-end view of where a message was. Some of those key components that we just talked about, I'm going to be discussing a little bit about the claim check pattern and the application sites custom events, right? So what we did with the claim check pattern, basically on publishing functions, what we would have is some kind of code that separate the metadata of the message, like what the message is about, IDs, like the type of message, what stage they were, etc., versus the actual payload. And then the service bus topic would have the topic would keep the metadata where the actual payload was stored into a storage account. Any subscribing message, what would do with that is they would first receive the metadata, and sometimes they wouldn't even need to actually go and pick up the content, right? So they could pick up the content, process when they require it, not always transferring the message. And the other thing that was interesting on that specific case is if the content didn't change between stages of the process, if you're just doing validation or something like that, you didn't need to create another copy of that. You could just pass the claim to the next stage, referencing the same data. That allows us to make the system much faster and much more flexible. From the custom events, what we did is, it would allow us to create the end-to-end traceability using a correlation ID. So the message that we received in the beginning of the process, we started to use to correlate events across the whole process, right? So something like that. I could have message 101 received and validated, then after that transformed, then it's stored and enriched, and then routed. It would also allow us to do for exceptions to be captured the same way, right? So if message 102 received and then something go wrong there, we could just throw an exception there or actually create a custom event of something that failed, right? We would have the exception, but we also have the traceability of a custom event that it failed. So think about BAM that we were talking before. You could achieve something like BAM with this custom event. You're actually creating the progression of the message and creating a really good observability for that. How we did that? First thing was leverage functions, app inside support. So as you got functions, you insert instrumentation key and said there's going to be using that. And a lot of tracing was already being meted straight away. But what we wanted was actually custom events, right? So from the custom events point of view, we implemented a reusable component. And that component is just injected in the beginning and at the end of process, so where we needed it to emit events. On that note, let's take a quick look at of some code. What do I have here? So I have here two functions, right? Is that a demo kind of replicating what we did for that client? And that first function, what it does, it receives a message on an HTTP endpoint, right? Then it's going to be uploading. Let's make it a little bit bigger. Better for you guys? Cool. So the first thing is we created a component that allows you to upload the blob into a blob storage, passing some configuration. After that, when that comes back, then you're creating a message, right? So that's my metadata setup that we're talking about, with a reference to that file name and the other information that we needed. And we'll be publishing that message to message bus. Okay? Not going down to the code yet, but I'll come back in a minute. From the service bus queue point of, from a reception point of view, or retrieving data from those topics or subscriptions, was even easier, because what we did was actually took advantage of the triggers and the inbuilt process from logic apps, or from functions, right? So what I did was I basically bind that to a service bus trigger and say that I'm going to be receiving the message. Then I'll just find my my file name, right? So just try to find the content or the name of the file, and I would go and get off that blob with that file name. So after that, I do like, on this demo, I did a lot of real processing, right? I logged the information about the ID of the message, and I logged the content. So it's like hardcore stuff. From the application insights point of view, basically what we did was just created a custom component that allow you to create an event. And in this case, we tailored, because we wanted it to be tailored to the application itself, we say, I'm passing the same message that you push in, the same metadata that you push into service bus, and emit some events based on that, okay? And that code is quite trivial as well. So if you look at the things, the create PNR event, so I'm just setting up my instrumentation key. I'm creating a new telemetry client using that instrumentation key. And after that, I just starting to set up a custom event, right? I'm saying track an event where the name is function name plus status that has that set of properties and those metrics. And that was it, right? With that, I was be able to like create, start, create, end, and keep like tracking of all of that in a really simple way. Let's see if that's working. Did you guys sacrifice any of the lunch for the demo gods? I forgot. So I hope there is someone did that. So that one is going to be running locally, right, and not pushing the function to the function to the cloud. But everything else, application insights and the service bus, is on the cloud. Okay. And one thing that you're going to notice here that is quite important to see is how fast functions are compared to the polling process that we have for logic apps, right? I cannot just go back to service bus and show you that the message is there, because as soon as the message hits service bus, logic apps is going to be receiving a notification and push that message straight away. So what we're going to do here is I'm going to be sending a message with message ID 1236 and saying the usual prayer. Please, demo gods, make this work. All right? Because it's always good to be nice with them. Cool. If everything goes fine, what we're going to have here is the message going, and we're receiving back that PNR message that we created, right? With a file name and a message identifier. Okay? And if I go to my no show of hands, let me duplicate that. If I go to my Wagner storage, to blobs, integrate 2019. Which one? What time? So which one that are we looking for? We're looking for 7E4. 7E4 at 2:55, right? And if I got that, there we go. So it went all the way to the to service bus. But the other thing to notice here is, if we look at that, can we do that? No. So if you look at that bit here, as soon as you send the message, service bus received the message, triggered function, and what I did there was like, yes, I received the message, right? So I execute that trigger, and the service bus queue trigger function process message blah, H6A0. Which is, no, that's the message unique identifier, sorry, right? With file name 7E4 JSON. And the file content was that. So my process was allowed to get the message, and after that, call the get blob part and push the information. So although it was, let's go back here. Although it was a process that was kind of manual, right? Today would have easier ways to do that. We managed to implement that claim check pattern relatively easy. Okay? Before we go here, the only other thing I want to show you is the information about the application insights. Application insights usually takes a while to synchronize, so there is a chance or not that you're going to see that extra message here. But you can see like already a couple of the other ones that I did that I prepared earlier. All right. So if I run that, I actually have that one there. Thank you, demo gods. You're really good today. And since that's the last demo, I probably should be on the clear. So see that it emitted the receive message completed with the information that I pass about the thing, right? So if I was working with that, with the same correlation idea across multiple steps, then I could start receive messages, the receive pipeline started, receive pipeline completed with that information, the validation started and completed, or the process started and finished with error, right? And with that, it would be like full visibility on that. You give a couple of those other queries to support, and they can find exactly where the messages are or what had happened with that. Okay? Some other things to take a look here. One thing that was quite important for them was the security, right? On that demo, I didn't show any of your keys, any of the keys for you, because to be quick and dirty, I put everything on configuration files. But on the real implementation that we did, we leveraged from MSI support, so the management service identity, what is available, right? And SQL Server, for example, we just created a service principal for functions and say, hey, connect using the service token, give permission on SQL, and that's it. There is no key store anywhere. For storage, the same thing. right? And when you needed to access Key Vault, same thing. Why did you need to access Key Vault? Because in some cases, like Service Bus, didn't, at that point still didn't have the MSI support. But instead of storing that somewhere, we still got the connection string from the storage account, from the Key Vault, right? So that makes sure that it was a really a much easier conversation with the security team, because remember that you're talking about a government agency in this case. They would be like all over the place around rolling keys and things like that. With MSI, you don't need to roll keys, right? And in places that we needed to roll keys, it was totally under their control because we're storing that in a central location that was Key Vault. From exception management and retries, what we needed to do, basically, we just created a catch block using a notify and throw, right? So we would be basically throwing stuff down to the application insights, and then after that would be throwing the error. And the reason why you're throwing the error was because in some cases, if you think about Service Bus, for example, if you exit, you didn't see me just going on that message and completing the message, right? That was everything was done by the binding from functions for me. So I receive the message, and if anything goes wrong with the message, it keeps the message on the queue until I finish my retries. But if I finished the process cleanly, it would go and remove the message. So all of that was done by the platform for me. I didn't have to worry about any of that. Right? So that's what I was saying, is leverage function Service Bus to do the pick lock pattern in a safe way. What we did is we adjusted the maximum delivery count on Service Bus to not retrying excessively when we don't need to, right? Because in some cases, for example, when you're picking up from the message and doing a validation, we'll be throwing an error for validation, but I don't need to try another 10 times before I know that it's actually wrong. But I wanted that message to still go to the dead letter queue because I wanted to process that later on. That's what we're going to see later. The message that's failed would always deliver to the dead letter queue. That means that I always have a copy of that, and then I could explain to the customer why it failed, or I could do another retry if it was something like network related. So I have a whole lot of other more options for that. Talking about DLQ management, what did we do? We created a set of logic apps to pull the subscription every 6 hours. So that means that we're not going to be keeping too much data on there. We're always managing the data, the dead letter queue, right? Instead of just grow that excessively. Each subscription could have its own logic, and that means that we move the reprocessing from Service Bus delivery count to actually an external endpoint, external message on the external metadata on the message, right? Because some of them, I wanted to have like a couple of retries. For example, when I push into SQL Server, I knew that like in some cases, I might be pushing so many things to SQL that I'm going to receive errors because SQL was too busy, right? But that would be like one in 10 or 1 in a million that would be happening. So I didn't want it to lose those messages, but on that case, I wanted to retry. On validation or some of the other things, I didn't want it to retry at all. So I externalized the logic about what I retry and how I retry to the data letter queue management. And in some cases, I would go in and do notification or sending emails or push information to Serilogs kind of applications, right? Like Splunk and things like that. So how that would be working? Sorry, just to complete, all my error message would also go to the blob storage. So if I send in notifications, I could reference the message to a different blob storage, right? Instead of having to go to the message that we had before. And in this case, like if I receive a message and that end up going to the dead letter queue, the logic apps would be receiving, would be sending a copy of that, and would be notifying someone with a reference to that one. But in some others, if I receive the message, it would go and try to push it back to the original topic with the same information, retry count bigger. And then later on, if I receive it again, I would be pushing a copy of that to the storage, and then I would notify. Okay? 1 year later, what would happen if I was going to be creating that same solution today? How I would be dealing with that? I would have new technology candidates to evaluate, right? And from that, what we could say is like integration service engine would probably be a really a good candidate. Would starting to think about doing the comparison between how much I pay on dedicated versus how much I will be paying on AIS, right? Because AIS would be giving me other stuff apart from just the certainty on price. For example, would be allow me to connect to the on-prem if I needed to, or pair the things with the rest of the network. I could think about using durable functions, or I could think about actually meeting events, real events to event grid instead of using just service bus, right? In our case, we thought that the functions would still be the right solution because it allows us to do a whole lot of flexibility. But here are the things that we could be considering today versus what we'll be doing before. And we have new features, right? And some of those new features actually would have a lot of impact on the service. The first one is, if we're doing that today, I would probably be using Azure Functions Premium instead of be using Azure Functions based on a dedicated environment. Why? Because it would give me the ability to have the things working really fast. That's one of the reasons that they go to dedicated. One was to avoid the code storage or the code start, but the two was for the certainty of the price compared to what we have on Logic Apps. Right, so we probably would be going with Azure Premium with like a minimum and a ceiling, and with that would be like probably having some cost savings, but still going to the same top if we needed to. With the improved support for Key Vault, then I would be able to make some of the things that I was doing with Azure Functions easier. But even better, with the improved support for MSI, I might not even need to use the Key Vault at all in some cases. And the other thing is virtual network support and service endpoints would allow me to actually restrict the solution better if I needed to use that in a more restricted environment. Some of the things that we learned from that, the first one was quite obvious when you're starting to do like, here is a solution, it works really fine. No, it doesn't work really fine, right? So review the fine print, make sure that you know exactly what is the limits of your, actually know that you know your requirements down to the point where you understand the volumes, you understand the sizes and everything, match that against the technologies and the limits of those technologies. Operational cost is a design consideration, and that's I've been saying since 2017, I think. Actually, that slide is from my 2017 presentation here at Integrate. One of the things that you have to think at the beginning of the process is how you're going to run that, how they're going to operate that, how much it's going to cost. Because remember what Tom was saying before, right? With the less control that you have, you can go to something that is really simple with PaaS, right? But you need to understand how it's going to be running at the long term, so you can understand how much it's going to be costing. And most of the cases, that can be like a really bad surprise for the client if you don't think at that at the beginning of the design process. You go and get everything working, and all of a sudden it says, well, it looks really nice, but it's going to be cost me $10,000 a month. No thanks. Right? Instead of thinking about that in the beginning and go to the right solution. Make the best of each technology, right? So get your technologies and then compose them together. We always saying that serverless is like creating Lego bricks. So making sure that the pieces fit well together. And the other thing is like, think about the big picture. One of the things that we find quite interesting on that one is that they needed to rush that solution for some kind of compliance. And in the end, the API management instance that they created, for example, was specific to that application. 6 months later, they needed to create their common services platform. And then all of a sudden, I have 2 API managements that I have to set up, or I have to start migrating things. So spend a little bit more time during design thinking about, do I need to create a common platform? What are the things here that are actually so reusable that I should be taking outside of the application and created that as something that the whole enterprise should be using? So in summary, weight your technology options, right? Understand what they do and making sure that they can work well with what you need. Think about the limitations, the operational costs, and understand how your solution fit on the big picture. What is the things that you could either reuse from external applications, right, or from other solutions on the company, or what we could create that as a common resource. And finally, understand the components roadmap. One thing that was quite interesting on our solution was you didn't see me deleting anything from the blobs, right? And they needed to manage that blob storage. But we just find out that the whole retention policy was in preview and was going to be hitting the things in 6 months' time. So why is going to be spending time writing a solution to delete blobs if in 6 months I'm going to have the ability to do that just as configuration? So understanding what the components are planning to and seeing if the timelines that they presenting to you matches what the organization can live with, then you avoid reusing or rewriting code that you're going to be throw away in 6 months or in 1 year. And with that, thank you for attending.
Cove.co